Hi, this is Hastings Math Videos. We're doing a Pearson EDEXCEL International A-Levels. Today I'm going to be looking at question 9 from the January 2023 paper. So this is the question 9 question. You can download these online, these papers, past papers, and follow on. Okay, so if you're somebody who likes to just look at the answers quickly and scroll through, then I've previously worked this out. So here is question 9 for you. Okay, so I'll just scroll through 9A, 9B. And we have continued using iteration. Okay, I can just pause the video at any time. Then we have here continuation. A little note on the calculator work over there. And that was 9E. So I think that's the end of it. You just check. That's question 10. Okay. But if you want some more explanations, I'm going to go through it now. Let's take a look. So question 9 has this little sketch and it gives you a curve equation. It says that x has to be larger than or equal to 0. Just always try and come back and check those sorts of things at the end. Make sure that there wasn't some reason for that. For now, though, nothing to worry about. So first question says find dy dx and give your answer in its simplest form. Okay. So doing question 9A, and they give you this curve. And the first thing I do is we had a square root. So the first thing I do is immediately just change the square root. So I know that it's the power of a half. It's the same thing. So just rearrange the equation to suit my needs. Okay. From here, we can use the chain rule. The way that I teach the chain rule is just using color. We're deriving, so we have to first times this by the a value, which is an invisible 1. So our dy dx is going to be a half times by the whole bracket. The whole bracket stays the same. And then the second step is you minus 1 from that. So it'll be to the power of minus a half, because a half minus 1 is minus a half. And then the third step is we have to times this by the first derivative of what's inside the bracket. So first derivative of what's inside the bracket, well, the 3 will just fall away, but we do have to deal with the 4ex squared. Okay, so first derivative 4ex squared. Quickly look at that. So 4ex squared, because it's e, it just stays the same. And we have a function inside a function, again over here. So we need the first derivative of the ex. So everything stays the same, times by 2x, which is the first derivative of the ex. Just look at where all of those things came from. Okay, so this goes up here. All right. I want to clean that up a bit. That's very messy at the moment. So a half times 4 times 2. It would be the first thing that, so we have a half times 4 times 2. So 4 times 2 is 8. 8 divided by 2 is 4. So 4. And then generally you'd put the x probably first and then ex squared, and then the whole bracket can go in. Okay. This is a negative exponent, so you probably want your final answer to be in a positive exponent form. Oopsie, there's the ex squared. Positive exponent form, you just, that whole thing is in the denominator. And in the denominator, it's a half. You could write this as a square root again, but I think this is full marks, so I'll just leave it like that. Okay. That was number A. Number B gives you some more information. So it's this picture. Point P lies on the curve, and it also passes through the origin. Okay. So because it passes through the origin, there's certain things we can know about it. Let me grab this for you. So what do we know about the origin? Well, we know that it's 0, 0. Okay. That's the first thing we know about it. The second thing we know about it is that line that goes through the origin is not going to have like a value for C, if that makes sense. The C value of this line that goes through the origin will be 0. So if we had some sort of line mx plus c, we know that that C by inspection is going to be 0. Okay. But if you don't think of that, you could just say that it passes through 0, 0. Both options are true. And we know that the point there touches both this purple line and the curve. Okay, then just see if they gave anything else. C passes through the origin. Show that x equals a is the solution of this equation. Okay, weird question. When I see is solution, I think, well, we're looking at point P. So if I name this pink thing L, we're going to let C equal L, because at point P, this happens, C equals L, and then rearrange it, in order to make it look like what they've asked for, which is this. They've asked for this. Okay, so I'm going to look at my previous working and just make sure that's what I actually did, or if I didn't, so I'll do that. I'll do both. Okay, let's take a look. So if I put this on the left there for you, number B. So I gave P the answer. Sorry, I gave them the random variables AY. Oh, so why did I do this? I did it because we have let x equal a, basically. Okay, so we know that P is A, which is the x at P, and some sort of Y that we don't know. Now, the next thing I would do is look at the format. If I look at the format of what they've given you in the question, I noticed that if we look at this thing, it's got X's in the answer. It doesn't have Y's in the answer. So we want our answer to be X's, okay, in our answer. Let me just grab this for you so you can have a look at it while we're busy working. Oh, that's enormous. Okay, we want to make our working look like this. This is what we're aiming for. And put it down there. Well, what do we have? We have our first derivative, which we worked out in question A. Just for space, I'll come back to that. So we know that our dy dx from question A is 4, just change the x here to an A. So this is exactly the same thing. I've just substituted the A in because that's what we've done. Okay. And I changed the square root just to keep with what I did before. It's the same thing as what we had before, just that the power of a half is now a square root. So nothing's changed. It's the same as it was. So we know that this is the gradient. This is the gradient of the tangent line. So if we look at our tangent line, we now have the gradient of this tangent line. Okay. I want the whole line, but what else do we know? So let's take a look at any tangent line. Any tangent line, so it's touching, those should be touching, is equal to y equals mx plus c. It's a straight line. And we have this gradient so far. But as I discussed earlier on, we also have c because we know the line goes through the origin. So c is equal to 0. So we actually already have our tangent line. Our tangent line is y equals this whole thing. Okay, let's take it from here. This whole thing, x. So for a squared all over the square root of 3 plus 4a squared x. And that's our tangent line because this was m. Okay. So now we've got our tangent line and we had our equation for c. Just go back to the question and grab so that's our equation for c over there. So our c was y equals square root 3 plus 4ex squared. And logically speaking, we know that we have to equate these two in order to find the answer. Okay, so you let c equal the tangent in order to find the solutions. So just in case that wasn't clear, the two equations are equal at that point there. So we let c equal to what I called L, which is my tangent. Okay. So if I just grab this, so we're saying this equal to 3 plus 4e x squared. Okay. Good. So here we have a very sort of ugly algebra going on. I just want to notice that I have A's and X's going on in my answer, and obviously that's not good. So for my thinking on there was to change the A's, but I'm just going to change them back because for me, A equals to X. If I just keep them all as either all A or all X, as this isn't working in the way that I'm doing it now. I'll change them at the end. So this was, let me just get this right. I can see that this is something that would cause a lot of problems. Okay, here I have it with all X's. So it should be an X over there and an X over there and an X over there. I think those are all X's now. So X and A are the same thing. Yeah, better to keep it all as one thing. Okay. Right, let's see. So now we have to rearrange this horrible equation. Trying to see what I would get rid of first. Well, the denominator is pretty annoying. So if I rearrange this, it's 4 ex x squared times by x. I just put that x on the numerator over this whole thing equals to this. Okay. So I'm just looking, these are exactly the same. Is there something that almost seems too obvious to me? I just wonder if there's something I missed. Hopefully not. Okay, so a square root times a square root just gives you the same thing. So for example, if you had the square root of a times by the square root of a, you would just get a left over. Okay, so in this manner, if we times both sides by this whole denominator, it's going to go over there. The square roots will cancel out. Okay. So we end up with 4x squared. So that was this x times x. Ex squared equals to 3 plus 4 ex squared. Okay, good. I'm going to take everything over to one side, and I'm going to take it to the left. Minus 3 and minus 4 ex squared equal to 0. Okay. Oh, I think that, let me just check. So all of a sudden we have this. And we're good. Okay, so that's number B. Good. Number C. Number C asks us to show that A lies between number 1 and number 2. Okay, so this is where the iteration comes in. So here's our formula. And, oh, where are we? Get that if you want to look ahead. So we're showing, oopsie, that X lies between 1 and 2. And that's because X is A. Okay, they're the same thing. That's what we're trying to prove. They say show that. And when we do these sorts of questions, the way that we show that in P3 is to use iteration. So the first thing is you let X equal 1. So the left-hand side of the iteration, they said between 1 and 2. So that just looks like f of 1. So if you let X equal 1, you can just write f of 1. And so wherever you see an X, you put a 1. Put this in your calculator. Keep it there because we're going to do the same thing. So this is f of 1. And I've done it previously. I got minus 3. Then you keep that there. Just change all the 1s to 2s. So it'll be 4 of 2, etc., etc., etc. And you're going to end up with 652. And the questions was to show that our value lies between the two numbers. So showing that our A value lies between 1 or 2. And the way that we know this is that the sign will change. So the sign was negative and the sign is positive. You can't just write this though. There's a requirement that you need to write something down. So you should write that the sign changes from negative to positive. And this is a continuous equation, which just means that, which just means that the equation it doesn't have any breaks. So for example, if we had something that looked like that, there's a hole in it over there. Okay. It doesn't have that situation. It doesn't have an asymptote. So therefore we know that A lies between the two. And that's really all there is to it. We can move on to number D. Okay. So first part of number D, it wants us to write this from B in this form. So we're just rearranging it to make X the subject. Now it's a bit of a weird question because the X is already in it. So I'm going to use this one. So if I take this one and I rearrange it, I notice that there's a square root in the answer, which means that the X squared over here will be on one side, because if you have X squared on one side and everything else on the other side, you'll have to square root it to get rid of it. Okay. So that's what I'm going to aim for and see what happens. If we aim for that, let's first take everything back to the other side. So we have 4x squared e x2. If you want to go ahead, I'm just keeping this on the right-hand side there so I can know what I'm going for. So we're aiming for that is equal to 4e x squared plus 3. So I just took those over the equal sign for now. Now we can just divide the x squared term by 4e x squared. What we do to one side, we do to the other. Okay. The 4's cancel out. Obviously, the e squared cancel, ex squared cancel out. We get x squared equal to 4e x squared over 4e x squared. I'm just splitting up the denominator. 4e x squared. Okay. Oopsie daisies. This is x squared. Last step, just square both sides. This is square both sides. So this cancels out and square the whole thing on the other side. You end up with x equal to, and I notice this is just 1 because 4ex over 4ex is simply 1. So it's the square root of 1 plus 3 over 4 ex squared. Okay, so we're close. We're not quite there. If we write this as in the numerator, we get x equals to square root of 1 plus 3 over 4 ex to the minus 2. Oh, excuse me. The whole thing. E to the minus x squared. Okay. Still doesn't quite look right. I'm going to try writing 1 as 4 over 4. We write 1 as 4 over 4. So then we've got 3 e to the minus x squared over 4. Still getting closer. So, excuse me. We have a numerator of everything over 4. 4 plus 3. So now I've got the plus 4 plus 3 e to the minus x squared. So this could be rewritten as a quarter. Whoopsie. A quarter times by 4 plus 3. Just keeping an eye on where I'm headed for this thing. And if we split this up, it's a quarter squared. Whoopsie. Times by that whole thing squared. So a quarter squared is just 1 times 1 is 1. So the square root of not squared, the square root of a quarter is a half, and we're there. Okay, so a little bit of algebraic rearranging. So once we've got there, we can move on to the next question, and the next part of the question. So once you've proven that it can be written in this form, we can start setting up our iteration. Right, so we're doing part E, and part E is the iteration part of the problem. So they've given you this formula. So it's the same thing as the previous one. So this was our formula, and all they've done is that for the iteration, you do x n plus 1. So just to note, this is if this is n plus 1. So for example, if we had our xn as 1, then it would be if our n was 1, then it would be x2. Okay. So if n equals to 1, then this would be x2. So whenever n equals to 1, then this is our x2. So they've given the general formula. So the only thing that changes from the formula that we had worked out in the previous question. So xn plus 1 is equal to a half is exactly the same. 4 plus 3, and then instead of the x over here, we'd have to have xn. Okay, so this one being one more than this one. So always just notice that. This one more than this one. Okay. I just want to make this as clear as possible. So for calculator work, the question asks, the question gives us that x1 is equal to 1. So our first x is equal to 1, and then it says find an approximation for a, which is the point that we were working with. So we have to use the iteration formula to find the approximation. Right. So our first one over here is going to be 1. Okay, so when we write the first one, we're going to say x2. If x1 is 1, then x2 will be this whole thing with a 1 there. Excuse me, x1. I just put it in a bracket. So it's this whole thing with a 1 there. And you can keep going like that. So n plus 1. So n being 2 in this case will be 3. N plus 1, 2 plus 1 is 3. And the next one would be this. Okay. And so on. I would just write 2 of these down, and then the rest you can kind of just write the answer. But what I really want to talk about is the calculator work. So if we start at x equaling 1, then all you really need to know is how to input this on the calculator. So you press 1. I'm just holding my calculator while I do this to make sure I'm saying the right thing. So you press 1 and you press the equal sign. Okay. This will store number 1 as your answer. After you've done that, so this is your first step, and this is to store as ons. Okay, so we've stored it. So 1 equals, we'll store it. The next thing you want to do is you set up your whole iteration. So you set this thing up. But what instead of where that 1 is, you're going to put ons. So you're going to write this. A half 4 plus 3 e negative, and then you hit the ons button, squared, and this should now put the first answer as 1, and then each time it will give you your new answer for your next iteration of the number. So let's set that up. So if I put it in my calculator, just quickly pause this video. So our second, our x2 is going to be the first one that you get. So as soon as you hit the equal sign here, you're going to end up with your x2. So I got my x2 as 1.129561676. And then once it's set up like this, you just keep pressing equals, but I would write it down each time. So x3 ends up being 1.099719368. I just want to go back and check what they asked in the question. I think they asked for 4 decimal places, but I'm not sure. The question they asked for was, what is x3? Okay, so this is x3. So this, we could just round off to 4 decimal places, and then they want a. So we've already answered I. This would just be rounded off to 4 decimal places. So you could round it up to, if we rounded this off to 4 decimal places, we'd have 70997, and then that 1 goes down. So that's it to 4 decimal places. So this will be our x3. But I haven't changed anything in my calculator. So when you're doing these questions, don't change anything in your calculator. Keep going and keep writing it down. I do think you get marks for writing down all of these answers. So I'm going to hit the answer again. And I'll just give you the list here. So for me, the X4 came to 1.106248644. So if you just look over here, that's the X4. I rounded it down a little bit too early in this working. You should give an extra decimal digit. I would say if you're aiming for 4, you should at least give 5 in your answers, because you're going to need to round it down at the end, and you don't know if you're going to be rounding up or down. So the question asked, what is A? The question asked, what is A? So the goal is to find A as close as possible. And the way we do that to 4 decimal places, we keep pressing equals until it stops changing. So as you can see, I got to X9. So this was X4, 5, 6, 7, 8, 9. I mean, I wrote all the way down to X8, X9, and I noticed there was a pattern that the 1050 was continuing. Okay. But just keep going until you're absolutely sure, because even if if you look at my X8, for example, was 1.10505, and that 5 would go up, but what if it had been a 4 and we don't know if it's going to maybe round up to 6 or something like that? So my X9, the 4 decimals were settling down nicely. It's 10506. But you can see that in your final answer, A rounds to 1.51. Okay. So just to make sure that you don't round off too early. I think that's the end of the question. I just want to make sure that we covered everything. So asked for X3, which we did to 4 decimal places, and the closest iteration, the value of A. Good. That's the end of question 9.